Welcome to Armchair Physics. Today we're talking about plasma globes and black holes. My son got one of these for Christmas, and actually I hadn't seen anything like it before, but they're fairly common. They're called plasma globes or plasma balls. I have a few other names. You flip the switch and you get this beautiful display of tendrils of light dancing around inside the globe. This actually immediately reminded me of black holes because there's a kind of black hole in the universe which is generally called an active black hole that actually does something really similar. So I thought today I would talk a little bit about the physics of this device and how it's similar to the physics of those celestial plasma globes all over the universe. So let's start with the ordinary plasma globe. The key thing that has to happen for this to work is the thing in the middle has to be put at a high voltage. Once you have it at a high voltage, well, nothing will happen just if it's at a high voltage. You know, when you see a high voltage sign, it's not like you see plasma globes near that high voltage. Voltage doesn't do anything until you give some place for current to flow. Right? Voltage is the potential for current to flow. So a battery has a voltage, but current doesn't flow until you connect it to your device or you connect a wire to it. Current can flow through a wire because the electrons in the wire are free to move around, and their motion is what makes electric current. So this electrode here is not connected to any wires, but it's in this chamber with a special selection of gases that can act like a wire. These gases are, first of all, very low density, and second of all, they're selected so that they are atoms that easily ionize into their constituent ion and their electrons. And so when you flip the switch, instead of it just being in air where nothing would happen, it's in this special environment where current can flow through the plasma, and you get this display. So how is this similar to a black hole? Well, these black holes, these active black holes, were discovered 100 years ago, actually, and they were described as a curious straight ray because what was seen was a galaxy and a little ray of light. Well, that ray is actually a giant current of plasma, much like the tendrils that you see in this lamp. And how does it get launched like that? How does it happen? Well, the ideas for this started in the 1970s with a now famous paper by Blanford and Znayak. And they said the key for this to happen, well, two things have to happen. Number one, the black hole itself has to get put at a high voltage, just like this electrode. And number two, there needs to be plasma surrounding that black hole so that the voltage can power current that ultimately turns into the jet that we see. And they explained how this is possible. And what has to happen is there has to be some kind of external magnetic field. Black hole itself will never get charged to a voltage, but if the black hole is spinning and there's a magnetic field generated by, say, some matter nearby that's falling in, it can actually get put at a voltage, a fairly high voltage, in fact. And where does the plasma come in? Well, Blanford and Znayak showed that the voltage is big enough that it actually rips charges out of empty space. You don't need any you don't need any atoms at all inside the globe to ionize into the plasma. That voltage from the black hole is so strong that empty space will just sort of spontaneously produce particles. At least if there was one or two there to begin with, the particle will get accelerated to high energies. It will emit gamma rays. The gamma rays will hit other particles. New particles will be born. It's a big, complicated mess. But at the end of the day, you get that energy out as a current that powers the jet. So it's really quite similar to this device, high voltage and plasma. Now, the one last thing I'd like to tell you about black holes and the plasma globe is they both have on-off switches. And this is very interesting. We understand what's going on here. There's a battery in this device that makes a current and ultimately gets this thing at high voltage. What's going on in the universe? Well, the Blanford-Znayak idea is it simply has to do with whether that stuff is there at all to make the magnetic field that gets the whole process going. So we think that the reason why some black holes are active, the switch is on, and some black holes are not, is just based on whether there's stuff around them falling in. So anyway, next time you see a plasma globe like this, think of black holes and the beautiful jets of particles that we see all over the universe.